Now this is a different type of question. I'll say rather that this is a good question. ABC Limited issued 10% debentures, okay, of face value of rupees 1000. Fine. Coupon is payable half yearly on 30th June and 31st December each year. Now this question is with dates. Bond is redeemable at 31st December 2020. So the coupon is paid half yearly. Face value is 1000 rupees. Coupon rate is 10%. So you'll be getting 100 rupees coupon per year. That is 50 rupees coupon each half year you'll be getting. Bond is redeemable as at 31st December 2020. As on 1st March 2013, current yield on the bond is 12%. Now here there is a catch. If you don't read the question carefully in examination, you will feel like this is the current YTM. And you will say, okay, so this is a 10% coupon bond and YTM is 12%. So let's calculate value quickly. No, if you do that, your calculations will go wrong. What it is saying, it is the current yield. It is not YTM. Current yield is 12%. Right? So you'll have to apply the formula for current yield. Okay. Now question is asking what is effective annual yield to maturity of the bond as on 1st March 2013. You have to calculate now YTM. And to calculate YTM, first you need to know the current value of the bond. And current value of the bond may be calculated using this current yield. So if you want to do it yourself, try it now. I'll wait for you. Okay. Hope you have done now. I'll do it for you. You know the formula for current yield is coupon divided by the fair value. So first of all, you will have to calculate fair value, which is second part of the MCQ. And how do you calculate fair value? Do you know the formula for the same? It is like this. Current yield is equal to coupon divided by current price. Now you know that the coupon amount is, you can rewrite the formula like this, that P is equal to coupon divided by current yield. The formula was current yield is equal to coupon divided by current fair value. So the current fair value or current market price is equal to coupon divided by current yield. Coupon is 50 rupees per half year. And current yield is 12% per annum. Obviously it is per annum. But for half year it will be 6%. So 50 divided by 6% will give you 833.33. That is the fair value of the bond today. It means MCQ number 2 should be solved first before you solve MCQ number 1. Once you know current fair value, you can easily figure out current YTM also. But this question is with dates. So therefore, it is comparatively complex. I'll tell you how. So here I start this question. And as per the question, today the date is 1st of March 2013. So I'll write 1st March 2013. If I like 1 MAR 13 and press enter, Excel will automatically take it in the date format. So the next coupon date will be 30th June 13, right? And then the next date will be 31st December 13, 31 DEC 13. Excel will and press enter. And up to 2020, this will keep on going. So 14, 15, 16, 17, 18, 19, 20. For 7 more years, that is 14 more rows. So I think it is up to 31 row number. Yes. You can see here 31st December 20 is written at the bottom of the selection. So I'll release the mouse here. How did I do it? I just typed the first 3 dates. First is today and then 2 coupon date. If I select these 2 coupon date and then drag it down, Excel will automatically keep on adding 6 months because manually typing each June and December will be lengthy. So I simply select 2 dates and Excel has got it that I want a time difference of 6 months and drag it down to 31st December 2020. And now look here. Here I'll have to pay 833.33 rupees to acquire the bond, and then I'll be getting 50 rupees. If you want to copy this down, you can simply double click here, 50 rupees. But the last amount I'll change it to 1050 because here I am getting the redemption price also. Okay. Now I cannot actually use IRR function because for IRR function or NPV function to be used, all the time gaps must be equal. After 30th June, the time gaps are of 6 months. But this first time gap is of 4 months, whole of March, April, May and June. And thereafter all time gaps are for 6 months. This first time gap is though for 4 months. Now this is the problem. In case of unequal dates, NPV function or IRR function doesn't work because NPV function of Excel or IRR function of Excel has inbuilt assumption that all the time gaps are equal. For unequal time gap, you can use X NPV or X IRR function. How do I use X IRR function? I'll tell you that. Just give me one moment. So this is equal to X IRR, bracket open. I'll zoom it for your convenience. It's not IRR, it's X IRR. When I type IRR, it simply asks me to input values. Guess figure I don't give. But when I type XIRR, then it will ask you 2 inputs. One is values and the other one is dates. Values and dates. So here I'll have to select first values, like from here to here, and then put a comma. And as soon as I put a comma, then now it is asking me to input dates, right? So now I will select the date range. Close the bracket, press enter, and yes, this is the final answer. I'll express it in percentage form up to 2 decimal points. 14.38% per annum. And this is the effective rate. So the compounding effect of the half year and everything has already been considered in this rate. 14.38% per annum. And mostly Excel gives this answer as continuously. Compounded rate. Now, what is continuously compounded rate? None of our business. But yes, if you are interested in knowing, that I'm telling you that this answer is per annum and it is continuously compounded. It is not half yearly or yearly compounded. It is continuously compounded within the year. 14.38% per annum. This is your YTM. So usually we use IRR function for the purpose of YTM. But IRR assumes that all time gap must be equal. In case of unequal time gap, even if one time gap is unequal, IRR function will actually fail and you should use XIRR in that case. So what if I use directly IRR and not XIRR? You can observe that in this case, the answer will not be correct. So if I select this whole range, see, the answer is, okay, just a minute. Oh, I'm sorry. I'll express it up to 2 decimal points. This is number 1 in terms of half year. So I'll multiply it by 2 and that also will become just 13.47%. So this is the half yearly rate and this is the per annum rate. Even though it is per annum, but it is compounded, and this answer is wrong because the correct answer is 14.38 and here we are getting 13.47 because Excel is assuming that there is a time gap of 6 months between minus 833 and plus 50. Well, it is not the fact. So in case of odd dates, better to use XIRR function for calculation of YTM. So fair price we have calculated, and now see 14.38% is the answer. Okay. XIRR in case of odd dates. Now, if fair value of bond as on 1st July 2013, now this is not an odd date, keep in mind, because the coupon date is 30th June. So on the very next day you are calculating the price. It means that the next coupon will be on 31st December and the time gap is exactly 6 months. Between two coupon dates, if you are calculating fair value, between two coupon dates, if you are calculating yield, then it will be odd date. But immediately at the coupon date, if you are calculating value, then your normal function will also work. If fair value of bond on 1st July 2013, that is same as 30th June 2013 is rupees 900, what is effective annual YTM? Now, here also you can use XIRR function. There is no harm. So if I want to calculate XIRR now on 30th June, so I will kind of change this question a little bit and I'll put that this date to be 1st July 13 and here I'll put 900 rupees. On 1st July 13 the price is 900. If I buy the bond here, my next coupon will be 31st December 2013 and thereafter it will continue. So equal to XIRR, bracket open, I'll select all these values and then I'll select dates also and see the answer here is, in terms of percentage, 12.42%. So the correct answer is 12.42%. If you want to deep dive into this concept, I'll tell you one more thing. But be cautious Now I am entering one danger zone. So if you are not able to understand what I am going to tell you, because no, it's not difficult, but I am opening a new door, effective rate versus nominal rate. If you're not comfortable with what I'm going to tell you now, you can simply skip it, sir. What if I use IRR function? Now there are no odd dates. So will I get the same answer from IRR and XIRR? And the answer is no, you will not get the same answer. First, this answer is half yearly. And the second thing is, okay, I'll make it double. I'll make it double, say, for example. So I can multiply it by 2 to make it yearly. Still, the answer is not same. You know why? Because this answer is compounded half yearly. That is, interest on interest is calculated only twice in a year. And this rate is actually compounded continuously. Interest on interest is calculated infinite times in a year. Continuously means infinite times in a year. Half yearly means only 2 times in a year. If you want to convert this rate into effective rate, you can use one formula equal to effect. No, I'm sorry, not this one. Rather than equal to exponential value of this number minus 1. Just a second. Huh? I'm just trying to do one experiment. If it goes successful, then we'll discuss it. Otherwise, we will scrap it. No, not in this. Yes, probably it is now. Oh, no. So I'll not say it is compounded half yearly. Better I will say it is compounded yearly, which is called effective rate. If a rate is compounded once in a year only, it is effective rate. If a rate is compounded more than once in a year, then it is called nominal rate. So with XIRR, you are directly getting the perfect answer. If you use IRR function, then you will get half yearly rate. But even if you multiply this rate by 2, you will get half yearly compounded rate. To convert that rate into yearly compounded rate, you will have to use this formula. Equal to effect, equal to EFF effect. Nominal rate is 12.06, comma, number of times it is compounded in a year is 2 because it is half yearly. So there are 2 half years in a year. Press enter and you get the same answer, 12.43, 12.42. The slight difference is due to the fact it is going 365 days, 366 days, and here it is just rounded off. That's why slight difference may be there. So to conclude, I can simply use XIRR function to arrive at the final answer, because here, even if in case of odd dates, XIRR works. But here the date is not odd date. The time gap, first time gap is also 6 months, and all other time gaps are also approximately 6 months. So I can use IRR function, but whatever answer I get, first I'll have to make it double from half yearly to yearly. But even if I make the rate yearly, it is compounded twice in a year. To make it an effective rate, I can use effect function of Excel. If you don't want to indulge into this, delete this. Last 5 minutes, delete from the video. and simply use this 12.42 thing and you'll get the answer. Right, sir? So this was your question number 42. We have to go up to question number 52 and total 17 MCQs are also there. So I'll see you back in the next video. Thank you. Enjoy. Bye-bye.